Hello there and welcome to this course on data filtering with Python. My name is Valentine and I'll be your instructor. In this course, we're going to follow this structure. So we'll get started with the learning outcomes. Then later we'll get to learn about what these data filtering techniques that we get to learn will entail. We'll also get to learn about why we apply them and who actually generally applies them. After that, we'll go into another session. That's a reading plus quiz session, where we will go through an in-depth reading of those data filtering techniques, and you will be required to complete a quiz to just check your understanding of your of those particular data filtering techniques. The idea here is that you need to have some theoretical understanding of what data filtering entails before now going through the practice work. After that, we'll go through now a practice session, and this will entail going through some curated notebook that we have prepared. And we will go through different data filtering techniques, as well as provide you with challenges that you would use to just be able to practice those particular data filtering techniques. So these are, this particular session will just involve the application of those theoretical concepts in relation to data filtering that we will have covered at the very beginning. We'll also provide a solution notebook that will have answers to those challenges that we're going to be providing. So this is an example of a challenge, but at the same time, you're going to provide the respective solutions to those particular challenges, as you can see here. After that, once we have completed going through the practice session, we will during in our next steps session, introduce to you a project that will come in handy when it comes to just applying those skills that you will have learned. And the idea here is that you get a real world scenario, and again, be able to see where you can apply those data filtering techniques in order to help an organization meet their objectives. So generally, that will be the basic approach that we're going to be going through. And I can't wait to take you through this learning journey within the next 2 to 3 hours, in the next 2 to 3 hours. And let's get started. So by the end of today, you'll be required to have achieved the following learning outcomes. You should be able to define the concept of data filtering and describe its purpose in data analysis and manipulation. You should also be able to describe the common use cases for data filtering. You should be able to apply data filtering techniques using Python to filter a dataset based on a specific criteria. You should be able to analyze the importance of data filtering for organizations, as well as be able to evaluate common data filtering challenges and propose strategies to address them. So starting off, what is data filtering? So data filtering generally is a process that we normally undertake as either data scientists or data analysts or even machine learning engineers. And it's a process that allows us to selectively extract and retain a subset of data from a larger data set based on some specific criteria. And the idea here is just to be able to have this subset data sets, that's a subset of data that allows us to just focus and work with only relevant information or records. And that would come with benefits. It helps us to just reduce the volume of data that we would need to analyze as well as process it. There are common use cases when it comes to data filtering. We would perform these techniques when we are performing data cleaning. So for example, if you want to filter out missing values, outliers, or any other inaccuracies that we would find in a data set, that is one particular common use case where data filtering comes into play. We would also perform data filtering techniques when we are performing data analysis. So if you want to maybe select specific category of records that are much more relevant to our research question, then in such a situation, data filtering comes in handy. When it comes to data visualization, we would need to filter first of all the data that would enable us create those data visualizations. So again, in data visualization, data filtering techniques come in handy. In machine learning, sometimes, actually most of the times, we would want to pre-process data in order, say, to remove maybe noise, which could be outliers within our data set, considering that sometimes the machine learning algorithms or models that we create would have the assumption that the data that you have does not have noise. So you would need to perform data filtering in order to remove noise, or even just balance data sets, or select the relevant features that would ensure that you have the desired results. In such situations, again, data filtering would come in handy. Lastly, in terms of data reduction, so sometimes we might only want to work with, again, a subset or a sample of an entire data set that would be representative of the entire data set, for various reasons, maybe for computational reasons, or for resource constraints that we might have reasons. So generally, data reduction would also be another common use case where data filtering techniques would be important. So generally, why is data filtering important? It helps us focus on relevant pieces of information. It ensures that we have good quality data to work with in situations where we would want to filter out missing values, outliers, etc., that may not be relevant to analysis. In some other situations, when we want to have some efficiency in analysis, then data filtering would be important. Resource optimization, maybe we wouldn't want to work with a big data set in the margin of in the gigabytes. We might decide to work with a smaller data set, and that would help us conserve memory as well as even save on time. On the other side, in terms of insights discovery, if we want to just filter for certain records that would help us just answer a research problem directly, then data filtering would be important in such situations. There are common data filtering challenges that we might encounter while performing data filtering, and some of them would be that we might be required to write complex filtering conditions. And in such a situation, what we would normally do is just break down the problem that we are working with, so that we don't end up writing complex filtering conditions that could sometimes be a bit difficult to understand for even other team members who would want to read your code. Handling missing data. Sometimes we would want, assuming that we want to use a data set to answer some sort of research question. If we apply data filtering techniques immediately, then we could end up with wrong results, wrong insights. And it's important to handle missing data or even just inaccuracies, just to ensure that the data that we are working with is reliable for answering the research question that we have. Performance issues with large data sets. When it comes to performing data filtering with especially large data sets, then it can become an issue. It can take a lot of time. Sometimes it can be resource intensive. So sometimes we might employ optimization techniques in relation to data filtering techniques that we are working with, and those would help us just go about such situations. Or we could even end up filtering only for a representative sample of or a representative or a sample of the entire data set that would provide just reliable results as well. String matching and text data. When we are working with data sets with just a lot of string data or a lot of textual data, then in such a situation, data filtering could be a challenge, but there are already techniques that we could employ still in relation to data filtering, but a bit more advanced. We could use data filtering techniques in combination with tools like, or other libraries like irregular expressions, which are suitable for, again, working with textual data. So those are just a few common data filtering challenges that we might encounter. There are many more, but those are just a few of them. Best practices. So when it comes to working with data filtering working on data filtering challenges, it's important to plan your filtering criteria first to just have a good understanding of exactly what you're going to be selecting. It's also important to use descriptive variable names so that you just have a good idea of the data that you're collecting, so that you also you have some consistency within your work. It's also important to document your filtering logic for other team members to be able, or other audience or stakeholders to be able to understand what exactly you took as an approach to filtering. Also, it's important to just break down complex conditions that would be and that approach would actually be less prone to just errors that might arise during your analysis. We've talked about data filtering techniques. And what are these techniques? These are techniques in relation to data filtering with Boolean indexing. We could use what is called Boolean indexing to apply data filtering. We could use the isin function method. We could use the query method. We could use iloc or loc method for filtering columns. We could use between method for just being able to filter for records between in a certain range. We could use NumPy masking for optimizing our data filtering operations. We could also use perform data filtering using date and time functions, which we'll get to see, as well as group-based filtering that allows us to be able to just have some summary information about a larger data set. Right, so that's it with regards to just a quick introduction to what data filtering techniques entail. These techniques would be performed either by data scientists, data analysts, or even machine learning engineers generally. So it's important to have a good grasp of these techniques before being able to perform further analysis. Additionally, in order to also perform these techniques, it's also important that you have just some good understanding of, just basic understanding of the Python programming language, as well as just being able to explore data. Our focus for today will just majorly be on filtering, not so much on that aspect of handling data. The same case also on handling missing data. Possibly you might have gone through a session on that. We also do have a course on handling missing data that would help you just set your data, ensure that your data is in the right shape before, again, selecting data for answering research questions. At this point in time, I would want to ask that you now go through the data filtering with Python document that we have provided, this particular reading, and it should give you a good idea in an in-depth way of what we have covered so far. Once you have gone through this reading, go through the quiz, and then just to check your understanding. And then once you have done that, we'll get started with our practice work. All right, so the next thing that we're going to do is to now go through the practice work. So open the practice notebook, and once you have done that, you need to save this as a copy. You need to save a copy of this notebook. So by going to File, then save a copy in Drive, File, save a copy in Drive, and what this will do, it will create a copy that you can be able to edit and save. If you don't do this, you won't be able to save your changes once you've finished working on the document. So please do this, and then we can continue. Once you have done that, you should have your copy open in a new tab. Just go to that and close this other one. All right. Once that is done, the next thing that you need to do is to go to Connect on the far right of your screen. You see a Connect button. Click on that to connect your notebook to Google servers. We're not going to be working with Python installed in your machine. So what we're doing is we are working with Python in the cloud. So we are working with a tool, a product called Google Collaboratory, which is a notebook, or it's an environment, just for ease of learning or understanding. It's an environment that allows us to work with documents that are called notebooks. So yeah, and notebooks are just documents that contain code as well as just text, and normally data analysts or data scientists would work with this with these documents. So once you have done that, then we can get started. So the first thing that we need to do is to import the prerequisites that we need for data filtering. And these are two libraries. There's the pandas library, and there's also the NumPy library. So the pandas library, we would use it for data manipulation, which we are going to largely use. And the NumPy library would be normally used for scientific computations, but you can also use it for manipulation. So we will get also to use that later onwards in another section when it comes to data filtering with NumPy. All right, so let's import those by just clicking on this button. Once you click on this, you might get this particular warning. If you get this, it means you haven't saved a copy in Drive. I did not save mine because I don't need to save any changes after. So I'll discard the changes now. But once you click on that, you should see a check on the left-hand side, and that should be good to go. Once you have done that, the next thing that you need to do, data filtering. We'll just need to expand the data filtering with Boolean indexing section. This is where we're going to understand this technique for when it comes to data filtering. So first of all, let's expand the first section under data filtering with Boolean indexing. And this particular type of technique allows us to use what are called Boolean vectors. Boolean vectors are what we would use to filter data. So the first thing that we would need to do in order to just see how Boolean indexing works, let's just load and also preview the data set that we're going to be working with. Once we are done, so we can understand this data set, there's an ID column, name, role, experience, SKUs, and full-time columns. So once we are done with that, the next thing that we need to do is now to define our technique, a Boolean indexing technique. And the first thing that we normally do is to create a Boolean vector, which is what you see over here, and save it in this particular variable. So a Boolean vector would just basically be some sort of condition that you want, say, you want to check for experience, the records with, well, it would be a condition that you'd have. So for the DF experience column, you want to get the records with experience greater than 5. So that is how we can be able to define a Boolean vector, as you can see here. Then once we have done that, we use the Boolean vector to index the data frame in order to be able to retrieve the records that we want. So we use this Boolean vector to index the data frame, and we store the filtered records in filter df, and we can preview them here. So these are the records that have an experience, have this value of have the experience years values greater than 5, as you can see. So with that is just it. We were able to now showcase data filtering with Boolean indexing. And the key thing is just being able to create a Boolean vector and later onwards use that to index the data frame. The next thing that we need to do is to apply multiple conditions in Boolean indexing. So assuming that this is just one condition that we had, assuming that we had multiple of them, how would we do that? We would use what are called logical operators. First of all, we would define those multiple conditions. So by creating multiple Boolean vectors, as you can see here, we have 3 of them, where role is equal to software developer, where experience is greater than 4, and where programming language contains Python. Later onwards, we combine those Boolean vectors using now a logical vector. It could be and, it could be, if we want to check, if we want to apply the OR operation, we would use this particular character, or not, we could use the tilde character as well. So we combine those conditions using the AND logical operator and save that in another variable, final condition, and then we index our data frame, as you can see here, and then we print out our records. And if we are to run this, we can see we have an error. So here it just basically means we don't have that column. This is the column that we need. So just update that. Yep, so I think that should be good to go. Okay, programming languages. Okay, we don't have programming languages. We could say skills. Yes, skills. So just change this to skills, and I could even just choose just the first skill. to compare with. Yeah, I run this. I won't get anything for now. But generally, that is how you can be able to get such a data. But what if I change this? I'll update this notebook so you won't have this particular issue. But for now, what if I change that? I should get the first record as well. So yes, that record, this record has shown up, and that just showcases how we can be able to apply multiple conditions in Boolean indexing. All right. Work on the challenges for that section and then verify your challenges with the solutions that we provided in the solution notebook. Once you're done, then we'll continue to data filtering with isin. Moving on, data filtering with isin. So understanding this function. So this just function is a function that we use to filter data frames for particular values. So if you have specific values within a column and we want to filter records with those values, then we can use this method. So let's first load our data set. This is a different data set. And this is how you can actually see how the data set looks. Then we use the isin function to filter out the data as shown. So first of all, we would define our condition, as you can see here. This is what we would define our condition. This is our condition, DF programming languages. So for programming languages, we want to check for either whether that record has Python or R, and then we get those records within that data frame that have Python or R. So, and we save that in filter DF and we preview that. Awesome. We can also do that with multiple conditions. Here we just have one condition, but if we wanted to have multiple conditions, what would we do? So let's load a different data set. This is a different data set than one that we had. And what we want to do is to have multiple conditions. So just for the first example, we had only just one condition, this condition, the one that I'm highlighting. But we can put some parentheses, like opening parentheses and a closing parentheses to define, that's our first condition. And then we can use the logical operator and then we put another parenthesis and define another condition. This is just an example. So in our case, for applying multiple conditions, isin functions with multiple conditions, that's what we're doing. This is our initial condition, the first one, where role is either software developer or data scientist, and we enclose that with a parenthesis, set of parentheses, and we use a logical operator and we also have another condition that we also wrap within some parentheses, and then once we have done that, we can print that out, and this is the outcome of that. And note that the logical operator, it's and, but we could also ensure, we can also apply other logical operators like or, whether those particular or this particular condition is true. All right, using isin function with negation. So assuming that we didn't want these, yes, we have these records, but what about the other records that are not part of this or not part of what we have in the condition, the other records? How we do that is we normally would use what is called a tilde operator. A tilde operator would be that operator that we would type through the use of the button that's usually right below the escape button on your keyboard. So if you press shift, then that button, it's usually on the left side also of the number one button on your keyboard. So shift and and you press that button, you will get the tilde operator. So let's load this other data set. And then we can decide to, so we defined our condition here, which you see here. But if we don't want now those records that belong to that particular, that we have in that condition, we use the tilde operator at the beginning. So you can see here, we have the tilde operator, which is here. And we'll get now those other records that are not part of the condition. All right, so At this point, work on the challenges and then verify your solution using the solution notebook. All right, moving on, data filtering using query. So it's query, sorry, this should be query. So the query function is one that allows us again to write conditions, but using what are called strings. So for instance, in our case, we could use the query function, but inside it, we have our condition, which we have defined and wrapped in quotes. So experience is greater than 4. Experience is the column name, and 4 is the value that we want to check. And we also use an operator, greater or less than operator, to be able to define that. If we have multiple words within a particular column name, we then would wrap those particular column names within delimiters. We'll get to see how we do that. So let's first of all load this data set and run that. We want records that have experience greater than 4. So once we have done that, we apply the query method with multiple conditions. So once you've understood now how do we do that. So if we have, say, in our case, multiple conditions, we can enclose those conditions in we enclose them in parentheses, each condition, and use an operator in between, a logic operator, and then do the same thing. All right, another condition is shown here. So where role is equal to software developer and experience is greater than 5. So let's load that and filter our data. All right. We can also use I think I've already talked about different comparison operators. We've already talked about assuming that you had multiple worded, we had column names with multiple words, such as years at a company. We would wrap that within delimiters, as you can see here. But again, in some situations, if you have multiple comparison operators, you could still use the same approach. If you can still use the same approach here. If you had equals or less than, equals is usually, this is how we write equal in that situation. But if you had even also multiple conditions, you could also write them as shown. Yeah, so no, it doesn't really matter much. So this is just another way of just writing of also just querying your data, but with just different types of comparison operators, as you can see here. So load that. And let's run these. You can also print out the other different data frames, filter data. All right, work on the challenges, and then once you're done, then let's continue. All right, moving on, using loc and iloc for data filtering. So we use these techniques especially when we want to reference column names. And first of all, we'll get started learning about the loc method. So the loc, or the loc function, we can use it to just filter data based on the labels or the column names. So for instance, in our case here, we use the iloc function, but inside it, so the iloc function has square brackets, and inside it we have our condition. But we define this condition with now the column name. So we want the role to be software engineer for that particular condition. So, and that's how we can be able to use the loc method for just being able to filter out the rows or columns that we want. On the other hand, when we want to use the iloc method is normally applicable when we want to even when we have some complex operations. So for instance, if we wanted to filter for data, maybe for the first 3 rows, last 3 rows, or last or the 50th, the 51st, or to the 55th row, then we can use the iloc method for that. So normally the iloc method would, or the iloc function would, we would use it when we want to filter data using what are called indices, integer indices. For instance, if we wanted to print out the first 3 rows inside that particular function, we would define that we want to select the first 3 rows as shown from integer indices 1. So the first record has an index 1 or an index 1. And then 0, sorry, not 1, 0. And then we define where we want to stop where we want to have our last record in that selection, and we actually don't get the that selection for that particular last record that we want. We get the one before. So for instance, from this particular operation, we are getting a record with integer index 1, 0, 1, 2. We're not getting 3. Let's load this. All right, displaying the columns using loc and iloc. So I think I will just give you a further complex operation in this particular situation with regards to iloc. But for the loc, I think there's a good idea of that. You might probably have a good idea of that. For the loc method, so here, so what happens is that if you want to have multiple conditions using the loc function, we would first of all define our well, actually, if you not really, yes, you can actually have multiple conditions, but enclose them in parentheses, but assuming that you wanted to specifically select certain columns. So we would do that by simply having a second, having to define the second parameters within this particular loc function as the column names that we want, but now we would enclose them in square brackets. So first of all, we define our condition, comma, then the columns that we want to select. That is how we can be able to do that. If also we want to select possibly the first 5 rows using the iloc method, so we can select the first 5 rows, 0, then up to 5 rows. This would actually select integers from 0, 1, 2, 3, 4, the records that have those integers, integer indexes, and then comma, now the records that the columns that we want to select the first the column with the integer index 1, 2, and 3, because this has 0, 1, 2, and 3. So we would get name, role, and experience, and we display that. Here we can even, let me just copy this here in a separate, close this in a separate cell, just to preview the first one, or we cannot be able to do that. If I run this, we'll be able to get the first 5. These are the name, role, and experience. This is for this particular output. But for software devs, let me run this again. We should now be able to see name and experience, which is based off this particular filter. All right, work on the challenges and then verify your solution with the solution notebook. All right, moving on, data filtering with between function. So we can use the between function to filter data based on a range of values. So for example, if we want to filter for records with experience between experience values between 5 and 10, this is how we can be able to do that. So we define our condition, but again, we use between 5 and 10. And you'll note that this only works on a range of integer values, or even just not only integer, but also float values. So let's load our data set, which is this, and we want to apply our between function. We want to get records that have certain experience values within a certain range. So experience between 5 and 10. So the outcome would be, these are the records with values between 5 and 10. We can also apply multiple conditions if we wanted to have multiple conditions. So we would wrap just the conditions that we had. So in our case here, this is the first condition. We would wrap it in parentheses, which you can see here. So this is our first condition, which is wrapped in parentheses. And this is our second condition, which is wrapped in parentheses. And we use a logic operator to add that. Take into account also this particular second condition. So let's load that and load this other one. All right, work on the challenges, and then once you've worked on the challenges, verify your solution. All right, moving on, data filtering with NumPy masking. So we would normally resort to this type of data filtering technique whenever we are working with large data sets and we want to optimize our code in other instances. Data engineers would also find this important. So the first thing that we do is just understanding what NumPy masking entails. So it's just a technique that allows us to filter data based on certain conditions. And first of all, what we would do when applying this technique is to create what is called a Boolean mask, which is just an array of true and false values that would just correspond to our data. So this is how we would do. First of all, by the way, we would create a Boolean mask and filter and apply this particular Boolean mask to our data frame. Not even a data, yes, to actually our data frame as shown here. But before we do that, we would need to create an NumPy array from the column that we are working with. So in our case, we would first of all create an NumPy array of those values, of the values of the column that we have, and then use those values to create a Boolean mask, and then apply our Boolean mask to our data frame, and then we filter our data. All right, if we have multiple conditions, if we wanted to apply multiple conditions, how would we do that? We can use, so here we used this method np.array to actually have to create an NumPy array from this particular column. That's one method that we can do, but we can also use another method where we have our column, then we just say to NumPy, same case here, to NumPy. So these are the columns that we want to apply our filtering to based off these columns, and we actually create these columns so that we create NumPy arrays from these two columns, and then we create our conditions just as we did here. We create actually not even conditions, our Boolean masks, but now we are doing that for both, and then we combine the conditions that we have, or the Boolean masks, and we apply the masks to the data frame that we have, and we filter out our data. So let me run that. Let's run this other one. Awesome. Work on the challenges and then verify your solutions with the solution notebook. Moving on, date and time filtering. In order to work with values, especially date-time values in a data set, we would need to first of all convert them in a format that we can filter them. And we normally would use the toDateTime function to be able to convert the values that we have in a certain date column to what is called a datetime function, or datetime, not function, a datetime format that we can be able to apply various data, various date methods or functions to. So how do we convert a column to a datetime, to have datetime, to have a datetime format? So let's load that, and we do that by using toDateTime. So data, date, this is the date column that we are working with. This is the column that we have. We want to convert it to toDateTime. So this is how we use the toDateTime function from pandas, and we inside that function we pass the column that we want to apply this particular format to. and voila, that's it. You won't notice any change, but if you are to print out the data type, so data dot d types, you will note that we have this particular date time data type. All right, so once we have done that, we can now be able to apply filtering. So once that's usually just a prerequisite for that. So, and that would just involve, say for instance, if we wanted to define, to apply our filter. So we would first of all create a filter, we wanted to create maybe some conditions. We would first of all create a mask for the conditions that we want. So for instance, here we have the first condition, timestamp is greater than start date, or and timestamp is less than or equal to end date. So our idea would be that let's run this so that we see the data frame, how it looks like. So this is the column over here, timestamp. This is another table. Assuming that we wanted to compare this table with, actually, this is the table that we have. So initially what we would need to do is to convert timestamp column into a datetime format column, or datetime format. So we do that using the toDateTime format, toDateTime function. And then here we're just defining the values that we want to use for our conditions. So date star dot timestamp greater than start date, or timestamp less than or equal to start date. Then we create, this is just going to allow us to have a mask for the time range or the date range that we want. We want to select records within this range. Then we apply this mask to our data frame. Then we print that out. And this is the outcome. These are the records with that regard that that satisfy this particular condition that we have there. On the other hand, we can use the between function, and instead of using this particular approach more closely to Boolean indexing, we can use the between function. We're just going to load the data again, convert the timestamp column to datetime format, define the start and end dates, and then create a mask for the date range. So we create our mask. So date range would be start date, end date, and then apply this mask to our data using the loc function and preview the filter data. All right, work on the challenges, and once you have worked on those challenges, verify your solution. Now, the last concept in relation to data filtering that we're going to be working with is called group-based filtering, and just involves first of all creating a summary table, and then later onwards performing filtering on that summary table. So it's as if you create a summary table, which is just a smaller table from a bigger table. And now the idea here is that what if you wanted to just filter for records from those particular tables, from that kind of a table? How do we do that? All right, so let's first of all understand what group-based filtering entails. So assuming that we wanted to create a summary table, we would create it as shown. So I'll even let's run this, and I'll create another cell to just demonstrate what that would entail, the creation of a summary table and how that summary table looks. So I'll just copy this, I'll paste it here and say grouped. Okay, we may not be able to display that, but what we would do is actually we are creating a summary table based off the role column. But let me even just explain further. So here we are saying grouped .df group by. So we are grouping our records based off the role column. Then later we are applying some sort of filter, some sort of condition to that particular table or group of records that we have selected based on the role. So we would do that once we have defined our group the data grouping, we then apply a filter function with a lambda function. Lambda is just another function. It's an advanced function that allows you to just be able to write efficiently functions. So what we are doing here is that we are grouping the data by role, and then later onwards filtering those groups with mean experience greater than 5. So for the groups that, if it could be software developer group of data analyst, if they have a mean experience greater than 5, then we filter them out. So we are actually applying our condition within the lambda function as shown, and we apply this particular function to our grouped data using the filter function, and we then save the outcome in filtered and preview that. In some situations, we might have multiple conditions. So if you have, so initially we had one condition. So let me load this again. So initially we had just simply one condition, which is here. So this is the first condition. We can use the parentheses to enclose that condition in parentheses, and we use the and the logical operator. Then we define our second condition as shown. So this is for years at a company, whether their values, their records with years at a company greater than 3 for the roles generally. And then we filter that out, and we can see what we have here. These are the records that will have been as a result of that particular filtering with multiple conditions. All right, work on the challenges, and then once you're done, go through the solution notebook to verify your solution. All right, so once you're done with the practice notebook, the next step that we would need to do is to go through the project that we've provided, and this will just give you a good idea of how you can apply those data filtering techniques that you've learned so far. It will involve just answering some critical research questions that will allow you to apply just the mentioned techniques. We've provided also a guiding notebook to help you get started, and this will just be a document that already has some code focused on that helps you to just focus on data filtering. So instead of writing code from scratch on how to work on this particular project, this particular document helps you to just get started with working on just that bit of data. So you would be required to just fill in the areas where you see that you have some code that's missing, and we've provided some code about data cleaning that you may not necessarily need to have gone through. You may not need to know, but you could always go through a different course on handling missing data, as well as performing data wrangling with Python. That will allow you to just see how you can be able to clean your data. But in the data analysis section, you will note that we haven't put any code, and this is a section where you will need to generally fill in your data wrangling code, data filtering code that will allow you to answer those questions, and then you provide your recommendations after. Once you have gone through this project, you can verify your solutions by just going through the solution notebook afterwards. All right, so generally that's it. That's it with regards to this course on data filtering with Python. In terms of next steps, once you have finished this course, even the project, you could always now look towards possibly enhancing your understanding on how to handle missing data, or even just now going to data visualization, because right now you would be, or even just not even the data visualization or data analysis, because you actually data analysis with Python would be the perfect course to undergo after you've gone through this course. It will just help you to be able to put data in a format that you can use for further analysis, like creating visualizations, or even just for machine learning purposes. That's it. All the best in your learning journey. If you did like this course, I can't wait to see you again in another future course, and all the best in your learning journey.